Hello and welcome to a short overview of polygons. We're going to be taking a look at solving problems with the sides and angles, and also talking about similar figures, same shape, different size, and congruent figures, which means that they are exactly the same. First of all, a definition or two. Polygon is a closed figure in a plane determined by three or more straight line segments. The straight line segments are called sides, and any point where two sides meet is called a vertex. Or if we're talking about more than one of them, we're going to use vertices, not vertexes. The union of the sides and the polygon in its interior is called the polygonal region. And if you see a problem referring to regular polygon, it basically means that all the sides are the same length and all the interior angles would be the same as well. So you're very familiar with these already. We have triangles, quadrilaterals, pentagons, hexagons, things like that. Basically, the prefix tri, quad, penta, hexa, hepta, octa, nona, deca, dodeca, icosa tells you how many sides there are. If you think about a triangle, for example, it has three sides, and the sum of the interior angle measures are 180. If you had a four-sided shape, like a rectangle, you could fit two triangles inside it. So it has a sum of two 180s, or 360 degrees would be the sum of the interior angles. So we're going to derive a formula from this, which is n, the number of sides, minus 2 times 180. We're going to talk about specialty types of triangles. So we have acute triangle, all the angles are less than 90 degrees. We have an obtuse triangle, which of course would have one angle that is greater than 90 degrees. We have a right triangle where we have a right angle. And we also have triangles we call isosceles, which has two equal sides and two equal angles. These base angles are the same. Equilateral, three equal sides, three equal angles, 60, 60, 60. And then we might talk about scalene, where all three sides are different lengths. If we use the term similar, that means you have the same shape but different sizes. So the corresponding angles would be the same measure, like B and E would be the same measure in angle, C and F, A and D, but the lengths of the sides are in proportion to each other but not the same. So you could use that kind of thing to know, for example, the heights of things, shadow lengths, and so forth. So here's one. Monique plans to remove a tree from her backyard. She needs to know how tall the tree is. She's 6 foot tall, and her shadow's 9 foot long at the same time the shadow of the tree is 45 feet long. How tall is the tree? So you'll notice you have two triangles. You have the little one that created by her and her shadow, and you have the bigger one created by the tree and a shadow. So the tree height is our unknown. We call that x. X is the height of the tree, related to the height of Monique, 6. The lengths of the shadow, 45, to her shadow, 9. And then we solve. This is a proportion, recall. So the fastest thing to do here is to cross multiply. 9 times x equals 45 times 6. So we have 9x equals 270, and then we divide both sides by 9. X is 30 feet. If you have two similar figures, or two figures you're looking at and the sides are the same and the angles are the same, we call it congruent. You could have a quadrilateral, four-sided shape, inside angles at up to 360. Of course, you have things like trapezoids, where you have two sides that are parallel. Parallelogram, where you have opposite sides are parallel, and then opposite sides are equal lengths. You have a rhombus, both pairs of opposite sides are parallel. All four sides are equal length. You have a rectangle where you have right angles and opposite sides are equal. And then you have a square where all four sides are equal and you have right angles. This would also be called regular, by the way, since all the sides and angles are the same. Here we are solving an angle of a trapezoid. Remember that this symbol means right angle, so this is 90, 90, 130, and they want to know x. Well, this is a trapezoid, a four-sided figure, a quadrilateral, so the inside sum of the angles is going to be 360. So 130 plus 90 plus 90, subtract to solve for x. Once we know x, we can subtract from 180 to solve for y. So again, 90, 90, 130, and x is 180, is 360, and x is 50 degrees. Then y would be 180 minus 50, or 130.